Hello everyone, my name is Priya. I'm the admissions tutor for the materials undergraduate programs here at Imperial College London. Many years ago, I was in the same shoes as some of you. I did maths, physics, chemistry, and accounting for my A-levels. I knew I wanted to be an engineer, but I wasn't quite sure which pathway I wanted to go down. I'd heard of chemical engineering, mechanical engineering, aeronautics, civil engineering, electrical and electronic engineering, and there are many more. I wrote to some of the engineering institutions in the UK, like the IMechE and the IET. The one that really caught my eye was Materials World that was sent to me by the Institute of Materials, as it was known back then. It had a conch shell in its cover, and it talked about biomimetics. And the further I read, I found out about material science and engineering, and that sort of hooked me into wanting to study material science. Discovering material science and engineering was great because that meant I could still continue to study maths, some aspects of chemistry and physics, and that's how I landed here at Imperial. I achieved my bachelor's in material science engineering, and then I continued to study my PhD in biomaterials and tissue engineering in this very same department. If you know you want to study material science and engineering, you will feel right at home here. If you are like me, unsure of what you want to study, you've come to the right place. Sit back, enjoy the presentation about Imperial Materials. That's a powerful message, isn't it? It's a video created with our partners to promote material science and engineering. So, what are the challenges of today and tomorrow? Whether it's energy sources, cleaning up pollution, innovative technology, an aging population, or even curing diseases. The key to discovering solutions is understanding. Understanding the chemistry of synthesis and production at nanoscale, understanding the solid state physics, understanding the biological sciences at a genetic level, understanding the ability of mathematics to computationally model, understanding the engineering design, and where and how all these fit together, that is material science and engineering. At Imperial Materials, The curriculum is structured in such a manner that we study how materials are formed or processed, how their compositions and structure lead to different properties, and ways to manipulate or control the synthesis to unlock their performance potential. We teach the fundamental science, but also provide our students with opportunities to develop their engineering skills from day one with project work. Material science is such an interdisciplinary subject. You gain knowledge and skills that allow you to step into any sector, whether it's new mobile technology with its bendable but unbreakable screens for your tablets and phones, energy efficient electric vehicles, advanced prosthetics that are integrated to your own nervous system, time and location controlled drug delivery systems, sports equipment that facilitate enhanced performance, jet engines that support faster and longer distance travel, space travel and exploration, quantum technologies. My point is, whether it's energy, manufacturing, automotive, pharmaceuticals, healthcare, communications, transport, every project needs someone with knowledge and understanding of materials in their team. Let's look at some of the research that's taking place at Imperial Materials. Meet Jessica. She's a research fellow in the department. She's the author of Nano, a children's book about nanomaterials. She specializes in polymeric chiral nanomaterials with wide-ranging applications due to their unique electrical and optical properties.
I'm really interested in carbon-based semiconductors. So these are semiconductors that are made from carbon, and they have the electronic properties of things like silicon, but the processing properties of polymers. And that means we can prepare different kinds of devices in really sustainable and environmentally friendly ways and make new technologies like more energy efficient displays, different biosensors, things that we could use to detect magnetic fields.
In the biomaterials and tissue engineering theme, research includes targeted drug delivery systems using self-assembling soft materials, using 3D printed extracellular matrices to repair soft and hard tissues, ultrasensitive and cost-effective disease detection using platinum nanocatalysts. Other areas of research include bioelectronics and soft robotics. In the world of renewable energy, there's a lot of exciting research taking place at Imperial. Let's listen to Robert Hoy, one of our lecturers.
As a materials scientist, what I focus on in particular is developing new low-cost solar absorbers. And what we're especially focusing on are materials that have a property called defect tolerance, because all materials at room temperature have imperfections, and these cause losses in energy that are irreversible. So we're looking at a new way of managing these defects. Historically, these defects have been managed by manufacturing the materials in a very careful way. Often that requires quite expensive equipment. Here we're looking at a new class of materials that can have these defects present, but can tolerate them to still achieve efficient performance. So you can have efficient solar cells made using much cheaper equipment that could be easier to scale up. And the quintessential example of these are a class of materials called lead halo perovskites. But these contain lead, so that's an issue because it's toxic. So we're looking at materials which are non-toxic, but which can replicate the ability of these perovskites to tolerate defects. So understanding how this comes about and how we can replicate these in the materials. So we work on developing materials as well as developing methods to manufacture these materials and then translating them into energy applications. So not just solar cells, but also devices that can go on top of a silicon solar cell to boost the efficiencies, or even devices that you can use indoors to power low-cost, low-power electronics for the Internet of Things.
You can listen to Robert's podcast on our YouTube channel. REF results came out in May 2022, put us in pole position for engineering research in the UK. Our research has been deemed world leading in terms of originality, rigor, significance, and impact. Moving away from the science, this is an aerial photograph of South Kensington. The department is based in the Royal School of Mines here at the corner of Exhibition Road and Prince Consort Road. There's a lot of culture around us, with the Royal College of Music right next to us, and the Royal Albert Hall opposite us, and the Royal College of Art not far. You just have to cross the road and you are in one of the largest green spaces in London, with Kensington Gardens and Hyde Park. This is a map of the college, and as you can see, the Byett, the south side, and the east side halls of residences are all within a few minutes walking distance from the department. We are one of the smaller universities in London where our undergraduate intake is only about 3,000 students per year. We are unique because we solely focused on STEM with just the Faculty of Engineering, Natural Sciences, and Medicine. Going back to the photograph, Gloucester Road Tube Station is at the bottom left of the image. South Kensington Tube is just off the bottom right here. Harrods, Harvey Nicks, and other shopping delights of Knightsbridge, right to the right-hand side of the image there. To the top, you have Bayswater and Paddington. And with Marble Arch right at the top of Hyde Park here at one end of the Oxford Street. So we are pretty central in London. These are a few photographs of the Royal School of Mines, the building designed by Sir Aston Webb, who was also one of the architects for Buckingham Palace. It has featured in a few films, the latest being Kingsman: The Secret Service. There's a photo of students relaxing in the summer by the Serpentine in Hyde Park, and one of an evening concert at the Royal College of Music. This is a photo of Commemoration Day in October, where about 3,000 students graduate at the Royal Albert Hall in 3 ceremonies. As a member of the Royal School of Mines, you also get an associateship of the school when you graduate. At Imperial Materials, we offer 5 different undergraduate programs, 2 at bachelor's level and 3 at master's level. The first 2 years are common to all these programs, so the entry requirements are exactly the same. So we advise you to only apply to one of these courses. Choose one of these as your 5 choices in the UCAS application. Our minimum entry requirements are based on mathematics, either physics or chemistry, and a third subject. There are no entrance exams, but we do have one-to-one and group interviews during our applicant day. We do have a minimum English requirement, and overseas applicants for the master's level programs will require approval by the UK government. Giving you a flavour of what's in year 1 and 2, students complete 6 equally weighted modules that are compulsory. In maths, you come across calculus, matrices, differential equations, vectors, probability and statistics, data analysis, and many more. You will study Python in computing. Structure covers topics like bonding, crystallography, and defects. In properties, you learn about plasticity, dielectrics and magnetism, fracture mechanics, among others. In processing, you cover thermodynamics, electrochemistry, fluid flow, heat and mass transfer, and so on. All of this is taught in relation to a wide range of materials. We have expertise on high temperature alloys to hydrogels and structural ceramics, thin films, and many others. Engineering practice is very exciting. In year 1, you do the design study where students get to problem solve. in a company of 12 or so students. You design, manufacture, assemble, and automate a solution to an engineering challenge. This is a video of their journey during a project by one of the teams. In the third and fourth year, you get to tailor-make your degree with selecting the modules you want to study from a variety, specializing in a niche area of your interest. Teaching is done throughout all 3 terms and over 4.5 days of each week. No Saturday lectures or workshops. The course is modular with workload spread throughout the year with lots of project work in teams. There's a minimum of 25 or 26 hours contact time during the first and second year, and it drops off slightly in the third and fourth year, where it's taken over by independent work and study. We realize studying and living in London can be expensive, so there are scholarships and bursaries available. You don't have to apply separately for most of the college or departmental-based financial aid. These are based on your UCAS application forms. There are others you have to make an application. These can be obtained from the scholarship search tool on our website. Super-curricular activities. These don't have to be expensive or work experience based. They could be as simple as reading books, listening to podcasts or TED Talks, or even watching engineering-based programs. Please look at the material science and engineering specific supercurricular list on our website. There's plenty of information about material science and engineering, the courses we offer, the application process, what we look for in your personal statement and reference, the interview process and how to prepare, careers in materials, profiles of our current students and alumni, taster lectures by our staff, and much, much more on our website. You can also virtually visit the department with Adam, one of our undergraduate students, and even experience lab demonstrations with our graduate teaching assistants. If you are interested in Imperial materials, please follow us on social media for our latest news and information about events and so on. You can also contact the departmental admissions team at the materials email address given here. Thank you for watching the presentation. We do hope to welcome you to the department in the near future. If you have any questions, please do get in touch with us.